Hi, this is Mohamed from Mental Graphics, and I will be presenting the poster related to generic SCSI-based host controller verification framework using SystemVerilog, in which we are talking about the host controller and a common test bench that we built to test different type of host controller that are SCSI-based. So let's start from the beginning. What mean by host controller? I will zoom in the poster to see to focus in each section that we are currently discussing. So host controller is or what's sometimes called a host bus adapter, a host controller card, or host bus adapter card is a hardware device that's connected between the host system and the storage device. And the main functionality is for the storage devices to connect the storage devices with the host system and used to exchange information with any peripheral device to to form the host system and relieve the host microprocessor of the tasks of storing and retrieving data, which is enhance performance or improve the performance of host system. So typically, this system is composed of three main components. PC having operating system running on it and connected to the host bus adapter card and hard disk drive. Okay, why the host bus adapter is challenging? Before discussing the details of and the challenges of host bus adapter testing, let's talk more in detail about the host bus adapter system. Usually, the host bus adapter host controller having an AXI interface connected to PCIe endpoint, which is used to be plugged into the PCIe slot into in the motherboard, and hence connected from the site to the host machine. The host machine is sending the PCIe transaction, memory read or memory write, and so on to PCIe endpoint, which is translated to an AXI interface that's derived directly to the core of host controller. And from the other side, the host controller is connected to through a X protocol link to the peripheral. It might sometimes it is a SAS or UFS and so on. So typically, this complex system to the host bus adapter verification and validation wouldn't be complete until it is integrated and tested inside this real host system and having the operating system running on the host system along with its host software driver or low level driver running on it. So this testing is difficult and is time consuming, and the system is so complex, and the bring up time is not something small. So if there's an issue in one of the host controller parts, usually a host controller is composed of two different parts, uh, software and hardware. So it's hard to spot any issue and finally fix it in the host controller in such a complex system. So having an environment that enable us or mimic the stimulus generated from host system driver, or mimic the real behavior from the host bus adapter from the host system side, would enhances the debugging capability and decrease time consumed in reproducing and fixing issue. This environment has a layer for generating SCSI commands that mimic the SCSI command coming from middle SCSI layer in the host system. Also, this environment can be applied or used with different type of host controller, and finally it can test and validate any change in the host bus adapter component. Okay, the test environment is composed of three main parts. uh, X protocol, the host bus adapter environment that act as a host system connected to the host controller, and the host controller is connected to its peripheral device. However, an important note here is that we are trying to trying to simplify this environment. So we consider that host controller has an exit interface connected to PCIe endpoint. So we decided to test the host controller without the presence of this PCIe endpoint that's showing here, uh, which uh, which simplifies the stuff, because having a PCIe link into such a test bench would complicate the testing and debugging the issue. So the main idea is to generate the stimulus starting from exit interface and bypass the PCIe endpoint. Okay, let's talk more about the details environment. Briefly, the different component inside the environment. This environment is, let's start from the left hand side. We have a testing scenario, different testing scenarios. Uh, we are dividing into three types: SCSI data scenarios and SCSI non-data scenarios, and they are common for different type of host controller. And X protocol scenario, for example, for UFS, you can have a special command related to UFS. You can send UFS query from the host system. Sending this command, this test scenario is part in the environment handling this special test scenario. So the transaction coming from here to the layer of generating data command and the SCSI command, and the data formation. Data formation here, the environment has a configuration for different type of queues, and this is a configuration. The queue depth is a configuration inside this environment. Data, the command is composed and written to what's called here system memory. It is a dual port memory and acts as a system memory, act as a host system memory inside the environment. And also the data formation. If there's a command that having data, the data is written also in the memory, and the memory is divided into three segments: data segment and command segment, plus the scatter gather list segment, and the third one was user space segment. This user space is used to store any protocol specific command. After the command is written into the memory, this layer is notify the data formation of the command is written in the memory data formation. The transaction is then sent to HCR register file command, which is write into the register file inside the host controller to notify the host controller that a command is ready. We have here two bridges. The host controller has two interface: exit interface for the register command, and the exit interface to be communicated with the system memory to read or write with the system memory. So we have two bridges that convert from register signals to exit transaction, and also from memory signal to exit transaction, which is simplify the operation inside the test environment. Okay. uh, this environment has been reused to test has this environment is basically developed to test the UFS host controller. Okay. And we have been reused it for testing the SAS host controller. So as a result of that, the SAS test environment was ready in a short environment, because the building block and the architecture was ready and got reused from the UFS environment. This environment has been reused from the developer in an early stage of host controller, which is the software and the hardware integration and accelerating the bring up time of the whole design. And also after the initial phase of using this environment to test an early version of the host controller, for example SAS or UFS, it was so easy to test the same host controller inside a real system. So also we were able to creating the live like test scenario and the basic and complex scenario, and spotting and fixing any issues in early stage compared to the real life setup. Okay, this briefly discussing the details of host controller test bench. Uh, uh, okay.